Hello and welcome back to module number two. And I will start today with a little bit about R and the background, but we will cover how to run R and how to apply it into our statistics and analytics analysis that we will learn. So let's start with the background a little bit as I covered that last time. So in often we are encounter with proprietary software such as Microsoft, such as Adobe. All those applications in the past used to cost money, and as a result, there was those programs has a lot of restrictions, inability to do a lot of things that we were looking to do. So as a result, there came a movement which called open source movement in computing that tried to open the source of the application and let everyone decide or run the application as they desire. So the idea was that everything is open to everyone to use, and it's based on the user demands and wants. Example of that is Mozilla Firefox. Another example is PHP programming, a web programming, where you customize it, but you need to know the code of the PHP or the code behind Mozilla in order for you to adopt and change the settings of it. Open source R, as I said to you, it is not only the 18 letter of the alphabetic, but it has a story behind it. And the story of the R started in 1976 when the first project was discussed in Bell Lab. Bell Lab now that was sold to AT&T, but in 1980 and 1990, John Chambers created the S language, and he tried to sell it to audience but was not very successful, and as a result he gave up on the idea of S language. And in 1995, two professors from the University of Auckland in New Zealand came up with opening the S language and open it to everyone. They named R because of their first name, Rose and Robert, so they call it R. The R language, as a computing language, is typically online coding. You will need to write a code in order for you to do that. But it has a lot of things that allowed us to do syntax and structure that is not so strict as Java or C++, and that's sometimes people do not feel comfortable with that. But this is something that a lot of data scientists take advantage and apply it to their own way of expressing or designing their own analysis. So the R language is an object-oriented language, and it is object because the object is the data structure that consists of the analysis and the language that we will compile in order for us to run the analysis in R. So one of the things that we talked about in the first module was the R packages, and there's a lot of packages in R. In other languages such as JavaScript and Python and even Java, we are seeing a lot of libraries, not as extensive as the R packages, but libraries that everyone likes to use. The advantage of the R package is that everyone can do that, and that's why it is so popular. Yes, there are some packages that are not so good and not very useful. However, it is the freedom for us to create something and maybe improve it in order for us to create the perfect analysis of the data or the perfect visualization of the data and create something new that never been done before. We will talk about packages later on in the semester. So the package basically is like a scientific journal document where it has the result, it has the methodology, it has the data set, and together they are able to generate the result that we're looking for in our analysis. So it's basically everyone can write a package, and in my next class in the spring semester going to learn how to write a package, so you will be able to present yourself not only as statistical a person with knowledge of using the R, but also to write a package that is compiled to your data set that you found. What are we going to do in the class again? Sometimes students ask me in the second module, so I'm going to repeat it. We are going to learn, in this module, we are going to learn about the syntax and the grammar of R programming. And then we're going to learn about statistical models. And we are going to do that through the eyes of probability theory and the idea of what is sample test, what is regression, what is correlation, ANOVA, multiple regression, and maybe in the end also to create your own model. You're going to create a project that you're going to find your data that you are desired to analyze, and you're going to demonstrate it using all those techniques of statistics and analytics in order for you to come up with result, an interesting result. So let's start with R. As I said before, you can download the console from the crane.r/project.org, and that's the interface. This is the interface that I started my exploration with R. And the other option is to install the RStudio. RStudio is more interface friendly. It is a lot of features that is easy to understand, and I highly recommend to use it because as a new R user, RStudio probably will be easier for you to work with in this class. One of the things that I like to highlight and cautious new students: do not install the R server application. You will be asked to pay. This is how they pay salary for their employees. The RStudio application is free to use. The R server is not. A server is something that you install on the web server and run it. Example, New York Times or the Washington Post. Have RStudio where they do their analysis of the data in the RStudio. So again, do not install the R server. The RStudio interface, as I said, it's much more simple. As you see, you have 4 windows, and each window has the ability where you're going to run the code, you run your code, and the console where you're going to see the result of your code, and the workplace where you're going to import data or see the history of your code, and see the plot in the lower window, the plot, the packages that you are using, and so on and so on. So again, the overall. So let's start with basic function in the R console and the RStudio. Help is really important, and usually help is one of the basic foundation of the R. And usually you will type help and it will come up and tell you what it is. If we will enter the following, and I bring with me the R, and I hope everyone can see it. So in this case, 2 plus 3, and I will say run, and he will give me the answer. 2 multiplied by 3, he will give me the answer. 2 divided by 3, and he will give me the answer. And if I will make it a little bit more complex, 2 divided by 3 plus 8 plus 5, he will give me the answer to it as the same way. So as you can see, it's straightforward and ability to do that, but I want you to be aware that where you see your calculation. Okay, so this is, yes. So the script, the console, and how to do that. So I talked about the R as an object language. You can save data into an object. Example, A, I call A an object, and I will entail or contain the value of 1. So if I will say A, and I will create a container with a number 1, if I will ask the R, what is the value of A, it will say A. I can add to it plus 2, and so you can see that using the R object, we can manipulate the data. The issue of good names versus bad names. Usually good names are short. Example, A, B, food first. Do not try to see some complex names that will mess up the name and the syntax of the programming language you are using. So try not to do a $sign or one trail or a square or dash bad. That will be a bad names, and I highly recommend not to use them. Next example. Again, I'm looking at the syntax. Height, I'm going to create a container called height, and I will give some measurements. 1.75, 1.8, 1.65, etc. And then I will also add BMI. And BMI will tell me that the weight versus the height, square root by 2, and I will ask what is the value, and this is how it will apply it. So basically, I created a function here. I did not define yet what is a function is, but I created a procedure that helped me to calculate and able me to add the numbers in order for me to abbreviate what the container of height holds on. Another example, weight, and I will say sum is the weight. And so if I will say sum, weight divided by length, in the container of weight, it will show up what it is hold on. And this is example from our textbook. Okay, so I hope that makes sense. Now I'm going for the main subject, the functions. And I created in Canvas, I created a page with the functions. And the issue is that a function is a type of a procedure or routine that emphasizes the evaluation of the expression rather than the execution of the commands. I gave a different definition to it on Canvas, again, to make sure that you understand the idea. So a function is a type of a procedure or routine. So some programming language make the distinction between a function which returns a value and a procedure which perform the operation. And this is something that is unlike R. R is running the procedure and hold the idea of it. So R comes with many functions, and I gave you a list of functions on one of the websites. So you can write your own function, or you can use a function that already embedded in the general R terminology or common functions used in R. But one of the things that you're going to learn very quickly is that in every package, usually they created their own function. And you will need to use their functions in order for you to calculate or extract the unique functions into your data set. This is something that I want you to be aware of it. And the issue of mean and the issue of factorial, here is an example. The textbook is also give you an example of it. This is a short list of R, and I gave the list also on the website. In computer science, argument is often used with the term the idea of the structure of the arguments inside of it. And in R, the argument can be raw data and an R object, or can even the result of another R function. Example, the mean is a function, 1 divided by 6, and it will be 3.5. Factorial is another function that we will learn about in descriptive statistics. And we can add to the factorial function a mean and 1 divided by 6 as a data container, and it will give us the result of it. When you're going to write the functions, and what we are going to do throughout the semester, we are not going to create the unique functions like we're going to do next semester. The idea here, we will use in this example a sample. And I will talk what is a sample. I talked about that in module number 1, but I will repeat it again in this slide. So a sample is a set of data collected or selected from statistical population by a defined procedure. The element of the samples are known as a sample units, sample points, or sample observation. To add to the function is the sample replacement that can be marked as true. So what is a sample replacement? When a sample unit is drawn from defined population and it is returned to the population, its characters has been recorded, and it can be a sample with a replacement or without a replacement. Usually we like to do it as a replacement, and that is in the case of true. Okay, hold on. So the function construct is the rare first class object, which means that it can be treated like any other object. Function also can be passed as arguments to other function. As I said, this is uncommon to common programming language. So the function can be nested, and it can be define a function inside another function. So in this case, the R has 3 basic parts: the name, the body, and the set of arguments. To make your own function, you will need to replicate those parts and store them in R. The syntax of the R function is usually the arguments that you are trying to make, and not every function can be remake. R makes all the formal arguments, and we will see that, or we will encounter that throughout the semester. Let's talk about basic terminology. And again, in this statistical class, we're going to talk about normal distribution. And normal distribution holds a role of probability and statistics, most because of its central limit theorem. One of the basic foundation that it's bridged the two subjects. I will discuss the normal distribution in the next module, and we will see that. But I'm talking about functions, and as you can see, the R function has the idea of R norm, and it's called R norm, and the purpose is generate random numbers from a normal distribution, and it will give us the following. And we also have probability distant function. And in this case, it will execute the following. And we have PAM norm, which is the idea is cumulative distribution function. And again, we will see those examples throughout the semester and we will apply that. I want you to start becoming familiar and try to search for those terms. Textbooks talk about that and we will see that more. So, example of a code in normal distribution. The mean is and the standard deviation, and those are the location of the distribution. For example, the length of any textbook may be normally distributed with the mean of 100 pages and a standard deviation of 16. The length of text produced before 2008 may be normal with 150 with a mean of 180 and then the standard deviation of 10. The family of normal can be standardized to normal with a mean of 0 and the variance equal 1. To achieve standardization, we are going to use the following formula. Z equal capital X minus the mean divided by the standard deviation. So in R, the normal distribution, and I gave it a data set or container that holds a data set of 116. And when I say calculate that for me, he will calculate the previous formula, which is the z-score, in order for us to standardize the numbers. And again, we can display it in histogram and the ability of how it will display. Just the syntax of the code itself. The hist is the name of the histogram, but in R, you need to define what is it inside. So we have the value of X, we have the probability is equal true. The color of the histogram will be gray with a 0.9, and the main will be equal the main mu equals 0 and the segment equal 1, which will display something like this. I will talk about what all those values next module. But for now, I want you to become familiar with the syntax of R and how the R discuss those things. The next subject that we need to talk about, again in the syntax of R, is a vector. A vector is a sequence of data element and the same basic types. Members of a vector are officially called components, and nevertheless we will call them members in this class. So here are a vector containing 3 numerical values, 2, 3, and 5, and we will hold them as a container under C. A container C is data container, and we can convert them into a vector logic values, or we can contain a characteristics string. And again, it can be AA, BB, CC, and again, those are the things that the vector and the logical values and the string can help us to communicate this data. When we are using logical vector as an index, when we use logical index, the position where the logical vector is true is returned. So in this case, this is how the code will apply and how it will display itself. Using a character vector as an index will display how it apply into the R environment. So I have a container which is called first equal 3, second equal 0, third equal 9. I will ask for the names and it will give it first, second, and third. But when I will open up and say, okay, give me the second, and the value, he will present to me the value of the character vector as an index, and in this case it will be equal 0. And if I will combine the first and the third, it will give me 3 and 9. Modifying the vector can be done too, and we are going to use it. In this case, we can modify it with adding value to it or modifying the elements less than 0. Again, those are the structure that we can do in order for you to fit the data that we are trying to do. We can also deleting vector. We can delete the vector by assigning null. And when we assign a null, it will clean up the container that we created in X, and it will display it is. The next data structure that is common use in R is the matrix. It's basically on two-dimensional data structure. So the metric is very familiar to vector, but additional container or dimension attributes is added. So the attributes of an object can be checked with the attributes, so the function can be deemed. So a matrix in R, in this case, you can see the plus in the container, which means that I add the following values into the matrix, and I can add a number of rows and columns, and I can go also to fill the matrix by row. And so if I will ask in the end what is really it provide me, you can see that basically it's not as sexy as Excel, but it will give me the idea of how the data is organized. We have top row and we have bottom row, and this is how it be assigned, and we can extract and manipulate it based on the row, based on the columns, and so on. Another way for us to store data in R is a list, and it is another way to store data. So again, as you can see, the C as a container that holds a list, or a container that holds value, index value, true, false, and so on. So I can combine them together and display it as a list. I can also slice them in the list. So in this case, I can retrieve and display or add into the container with the listing and be able to display it as it is with some additional components. Integer is the idea of store a whole numbers. It can be both positive and negative. To declare integer in R, we will use the function called as integer. So in this case, in the code, x is equal as integer minus 3, and when I will ask the R what is the value of x, he will come and say minus 3, and he will give us a note in the line 2 with a sign. So in this case, x will display the value of x. With class x, the print class of x, it will say it is part of integer. Another form of data collection in R is a string, and it is a type of data that in the integer that represent in the form of text rather than numbers. So it comprise a set of characters that can also contain space and number. For example, A with a container hello, and if I will say what is the value of A, he will say hello, and I can add to it 3 and so on. Another form of data connection or data display in R is the character. It represent a single element such as the letter of the alphabet, or a number. In order to convert object into a character values, we are going to use the function called as characters, and it will display it as it is. So X as a character, and it will show us to do that. When I use my own name, Alon, and my last name, Friedman, and I will ask paste Alon Friedman, he will basically act as a character based on my name. A factor is again with regard to exploratory variable multiplied by experimental settings, and we will discuss that too. So for example, I have a list of colors that I like to play in my art, and so if I will call it a factor and I will hold this container, he will display all of it, and the levels will be also part of how it will be displayed. Logical is another logical variable. The values are either true or false. So R, the logical value, makes a comparison between the variables and provide additional functionality by adding or subtracting, etc. For example, X equal 2, Y equal X equal 1 and Y equal 2. If I will ask, is X bigger than 2? He will say no, it is false. Last subject for today, and it is the idea of input data. And in the old console of the R, we used to have a procedure that we used to take the R Excel sheet, convert it to CVS format, and then upload it into to the R. There are several options to importing data from Excel to R, and usually we used to do that all the time. However, and this is hold on, I jump ahead of myself, but one of the things that nowadays is really easy to do with the RStudio is import data. So basically, it allowed us to import data based on text-based table, or from text to different type of text format from Excel or SPSS or SAS or etc. And we can upload it into the file, and let's look at that from this perspective. This is my my folder, and I'll show you an example of my own data set. Sorry, I did not prepare it from previous. Where my Excel? Sorry. Okay, so this is from social media, and so I have the idea. As you can see, it come up with a new interface telling me the name of the row, the maximum number if I want to have the sheet, and it shows me the attributes. I can use the import, and it will display it, and he will show me what it is. So basically, I import Excel into the RStudio as easy as it is, unlike in the past. When you have data from a website, usually you can write a code, and I will copy and I'll show you. Sorry, hold on. And you can apply it to the code itself. So he will ask, I did not copy the entire code, I just copy if I would be able to make it. Sorry. Nope, he did not like it. So let me open again. it doesn't allow me to write this. Okay, don't usually do that, so no, it doesn't allow me. So what I'll ask you to do is basically write the code as it is, and I will say example 3, and I will say read table, and I'll open the quotation, and I'll say read this data set, and I'll close it. And if I will hit run, he probably will come up with the resolution. So I will hit run and it will run it. So this is part of what you're going to do throughout the semester, and we will practice it more about the summary and how to do that. Last issue, again, this is the foundation, a data frame. This is something that all the programming languages such as Python uses the data frame, and the definition is basically contain a lot of data set that runs into one container that hold all those data set. So it has the idea of it contain multiple data sets such as from the web, from your own personal, and you can combine them into a data set. So it represents a list, and it allowed us to execute that. And the idea here again is the syntax of the data frame. So data frame, and I will call face, and I'll say breakfast. So in this case, I have 3 values. I have face, I have food, and I have value that I combine into data frame. And if I will call the data frame df, it will say, yes, you have face, food, value, you have and you have ace, breakfast, and 1, and you have 2, lunch, 2, and 6, dinner, 3, in order for them to match the structure of this data frame. I hope it makes sense. I hope that it will. I gave you more example of that, and so you'll be able to test it for yourself. So how to change a data frame from row to columns? You can do that. In other words, you can set a header for your data frame, and you can use it to define the name of the variables and under the data frame, and allowed us. So let me repeat with regard to what I did not talk about. I talked about in my example, but I did not talk about what it is, the types of data. In R, we have vector, we have matrix, we have array, we have data frame, we have list, and we have factor. All those type of data are part of our terminology, and we will see that throughout the idea. The vector is 1 dimension, the matrix is 2 dimension, the array is 2 or more dimension, data frame is 2 dimension, but its ability to hold a larger set of data. List is a collection of data object. Each element of a list is a data object. And this is the visual display of it in how to do that. Last issue, we are going to use GitHub. Why GitHub? Is the idea of sharing the code or our code, and I'm going to post all my code and all my examples that I'm going to present to you on GitHub. So you will be able to log on to my GitHub account and be able to take the data or take the R code or download the code into your computer. But the idea of GitHub is a little bit more philosophical, and I want you to be aware of it. We are talking when we are developing R packages or we are developing analysis, we usually have version control. Version control is that other people get involved in your project and allowed you to operate and to see what it is entail. That's part of data science culture, and I want you to take part of it. So to get an internship or a job, any company will have a use of version control because they don't want you to write code without anyone else see it in order for them to see what you are doing. So this is part of the culture, and you're going to use it, and you're going to share it in your blog when you write your blog, and you share it the files that you created. So this is the instructions. I talked about basic workflow. This is a little bit more advanced in our next class, but I want you to see what it is meant and how it apply. But we will talk about GitHub later on. Don't worry. I know that I talk too much, and that's a long session for us. But in this case, I talked about the syntax of R. And R is part of the GitHub repository. So you have the ability to store all your code in your R repository, and which is a really important thing. But we talked about functions, we talked about vector, we talked about numeric, integer, string, characters, factor, logical, and how to import data. We talked about data frame, and we talked about GitHub. All of it is also summarized in Canvas. So I hope it makes sense. If you have any questions, please do not hesitate to email me. Until next time, I hope you enjoy it. Thank you.